Good morning, campers. So I'm recording this one from my hospital bed while I'm stuck in San Antonio. I actually feel fine, and everybody keeps coming in and asking me if I'm the patient because they don't believe it because I look fine. So, because I'm here, I'm going to have to drop in and out on this, so I'm sure it's not going to be the smoothest of videos. So I'm going to try to get your video done so you guys can have this and for your test before you guys get started on that. So this is for Unit 1. This is all the stuff that we've been through, real numbers, scientific notation, and all that other fun stuff that we have been doing. So number 1 says, which sections would the numbers -7, 8, and -4 be placed in according to the chart? Now, this chart is a little bit different than the ones that we have been messing with. I know it looks different. You guys are used to it looking like something like this. It's the same set of stuff where irrational is off to the side. It means the exact same thing. It's just this circle here is not a rectangle this time around, but it means the exact same thing, okay? So let's start labeling these. So -7, we'll start with that one. I'm going to write -7 here. I know that -7, actually I'm going to write it in the circle to save a little bit of time. -7 can go, it's not a natural number, we don't naturally count to it. It's not a whole because it is negative. It's going to be an integer because it's negative and it doesn't have any parts to it. No decimals, no fractions, no percents, no nothing. So it's -7 and we'll go all the way out to real numbers. So now I'm going to come over here and label it real quick. So -7 is going to be a integer, it's going to be a rational, and it's going to be real. Keep this here so I can go ahead and get these other ones knocked out. Then we've got 8. Well, we can naturally count to 8, so 8 would go there and then all the way out. So 8 is going to be a natural number. So 8 is our natural, whole, integer, rational, and, well, real, and I ran out of room, so I'm not going to write real this time. And then -4 is going to go right there next to good old -7 all the way out. So -4 is going to be integer, rational, and real. It's bugging me that I didn't write real here, so I'm going to tag in real quick. Get it? Real quick. Alright, bad joke for the day. Alright, on to number 2. Robert and Dora need to write, 100,000 million billion, 4,300,000,000 using scientific notation. Robert claims that 4,300,000,000 is 4.3 times 10 to the 8th, and Dora claims that that number is 4.3 times 10 to the 9th. Whose number is correct and why? So, forget Robert and Dora. We're going to trust ourselves on this one. I'm going to come right here to the number, and we are going to write it in scientific notation. Our decimal is currently right here. We need it to end up right here. So I'm going to go and start writing the number out. So it is going to be 4.3. Sometimes I write 0. You can have the 0 there if you want to. But 4.3 times 10. And to get from our decimal here to over here, blue to red, my bad. Anyways, we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And it's a positive number, or it's a positive 9 because that's a very large number. It's not a small decimal number. So let's go see who was correct. Good old Dora. She must have been exploring all that math. Alright, number 3. A researcher measured approximately 0.005123 grams of bacteria in a sample. How is this number expressed in scientific notation? So I'm going to zoom on in. You'd think scientists would be able to figure this out for themselves, but apparently not, because we needed something that made sense. Here's our decimal. Here's where we want it. I'm going to go ahead and write that number out. 1, 2, 3 times 10, and then we've had to move the decimal 1, 2, 3 places. Now, if you're getting confused by the positive or negative, this number, that's a really tiny number. So it's going to be a -3. That's what we're looking for. Alright, number 4. Lucy estimated that it would take 4,000 grains of sand to make a pound. That would mean that each grain of sand weighs 1/4,000th of a pound. In decimal form, that would be 0.00025 of a pound. Express this in scientific notation. That's not really a question, but we're going to go with it. Okay, things I need you to realize on this. This right here is what they want us to express in scientific notation. This is just, this is all part of the story, but we don't really need that. She knows that that is the same thing as that. but we don't need any of that. We are only concerned with this number right here. So I'm going to go ahead and find my decimal. There's my decimal where it's at. Here's where I need it, between the first two numbers that are not zeros. So our number is going to be 2.5 times 10, and now I got to figure out how many places we moved it. I'm going to count this a little bit differently to maybe might be a little more visual. We moved the decimal from here, and we moved it 1, 2, 3, 4 places. So it's 4 places, and it's a small number, so it's going to be negative 4. So 2.5 times 10 to the negative 4th. Alright, moving pretty quick. Let's move on. Number 5, a microscopic cell measures 3.8 times 10 to the negative 4 centimeters in diameter. What is this number in standard decimal notation? Okay, going to zoom on in. I know we're converting this, so I'm going to go ahead and write 3 and 8. I know where my decimal's at. We have to move that decimal 4 places. Now, it's a negative 4, so that means our number is going to be small. We don't want to move it this way. We're going to move it that way. So our decimal is currently right here. So I'm going to move it over 1 place, 2 place, 3 place, and I'm going to have to move a little bit, 4 places. So our decimal ends up right here. So now I'm going to fill in my 0, 0, 0, 0, and I like having 0 before the decimal. You don't necessarily have to have that, but I'm going to rewrite that. So that is 0.123 zeros, 3, 8. That is our number in standard notation. Alright, number 6. It says the number 0 is located in which set of numbers? You can always go back and cheat and use the other chart if you need it, but I'm pretty sure... Oh, we've actually had this labeled already, okay? So remember that here on the inside, these are our counting or naturals, whole, integer. Oh, I'm not really sure what I'm writing there. I'm going to write over top of it. That's supposed to be an R. My handwriting is terrible today. Sorry, guys. Oh, wait. It's terrible every day. And then here is rational. There's my dot. Alright, so 0 is with the whole number. So our answer here is just whole. But just to clarify, it is whole, integer, and rational as well. Alrighty, and on to the back side. So number 7 says list the numbers in order from the day of greatest increase in depth to the day of greatest decrease in depth. Greatest to largest, okay? Oh, I just said that totally wrong. Greatest to... Wait. Oh, Lord. I hate when they use the word greatest twice. We're doing increase to decrease, okay? So we're going to go smallest number to largest. So over here, I'm going to convert all of these right fast. You guys get your fancy calculators. I have my iPhone. iPhone will work fine. But I'm just going to make these all decimals anyways. So I'm going to write this out to the side. So negative 0.3. I already know what 1/4 is. It's going to be 0.25. That one's already a nice decimal for us. 1/5. I think that's like 0.1. I'm going to double check it because my brain is fried here. I've been sitting here in this stupid bed for too long. So it's 0.2 and 1/8. I should know this by now, but I don't. So it's going to be negative 1. Oh, nope. Let me back that up. Negative 0.125. Guys, I can't stress enough how much you guys need to have these extra zeros in here. We've got 3 decimal places on this one. I'm going to put 0 there, 0 there, 0 there, 0 there, and a couple of zeros here. And keeping them all lined up. Alright, so the smallest number we are going to have is going to be Monday. And off to the side, I'm going to label these in what order I need them in. So the smallest number is the largest negative. So Monday will come first. That will make Friday come second. Now we're just going in regular old order. So that's going to make Wednesday come third, Thursday come fourth, and Tuesday fifth. Oops. Alright, now, again, this isn't multiple choice. I'm just going to leave it labeled just like that. So if you got any questions, you can label it out if you need to. But, when you get it on your test, it's actually multiple choice. So be ready for that. Alright. In ascending, we're going to ascend. That means go up. So again, I'm going to change each of these to a decimal. Okay, these numbers look a little bit weird. I'm going to assume that this is negative 2 and 3/8 because there's no comma before it. So I'm going to start labeling this. So I've got negative 2. Now I need 3/8 as a decimal. So I'm going to do 3 divided by 8. That's going to be 0.375. This other one is already a decimal, so negative 0.85. And I'm going to add an extra 0 to it. 4/3. I think I know that, but again, we need a calculator. That is going to be 1.3 repeating. So I'm going to get a couple extra zeros on here and label that for myself. That's going to be, next one is 1 2/5, which I'm pretty sure is 0.4. We're going to check it. Yep, 0.4. Oh, I'm trying to get my pen to work. 0.4, and I'm going to add on my extra zeros. 8/6. I have no idea what that is. So that's going to be negative 1.33 repeating. And then last one is 0.8. So 0.8. Sorry, I know I'm writing over that next problem. Okay, I already forgot what we're doing. We're doing ascending order, right? Which means we need least to greatest. Our smallest number that we have there is the very first one listed. So I'm going to kind of write over top of this for myself. No, I'm not. I'm going to label these. Negative 2 3/8 is our first number. I'm going to mark this out because I'm done with it. Which means negative 1. That's our second to last number, so that is going to be this one here. This will be number 2. So it's going to be negative 8/6 next. So we're done with that one, done with that one, which means that our next negative has to come next. So that'll be negative 0.85. Done with that one, done with that one. Now I gotta start thinking clearly again because now we're back into the positives. So our next highest is going to be that 0.8. So 0.8. I'm running out of room quickly here. Done with that one. Done with that one. And then the negative. Oh no, not negative. 1.3 repeating was that 4/3. So then it's going to be 4/3 and 1 2/5. All right, now I got to come back over here. I got to erase this because I can't read what I got. What number set represents section A in the Venn diagram? So I'm going to come over here to section A, try to figure out what on earth this is. Oh, I'm having trouble with my pen working again. There we go. Okay, section A. This is a weird looking chart. Okay, things that I do know. I know that pi is irrational. So that's going to be my irrational side, which means that these are going to be my rational numbers. Let's see, this is an integer because it doesn't have any parts. And I know the integers are inside of the rational part. So this is kind of backwards from our normal chart. So if I've got rational over here and integers and I've got irrational over here, that means it's usually divided up like this and they've got it flip-flopped on us, which means that A is just our real number system. So that one wasn't too bad. So section A is real. It's everything. Okay, more ordering. This is always fun, especially because I don't have a good old calculator with me. That we are doing greatest to least. You've got to watch out for that. So, square root of 51. I'm going to have to do this on my iPhone because I got it here with me. So this is going to be, I'm going to write this on the side, 7.14 and 1. It's a whole big old long number, but I'm not going to mess with it too much right now. Then we've got 7 square roots of 2. Ooh, I don't know if we've talked about this yet. I'll have to bug Miss Finley. Make sure he mentions that to you guys. That is like 7 times the square root of 2. So I'm going to do square root of 2 first, and I get 1.41, which is funny. And now I'm going to do that times 7. So this comes out to 9.899. Then we have 7 and 8. I'm going to get some extra decimals on there, or extra zeros on there. Alright, so greatest, the largest number that we have there is actually that 7 square roots of 2. The next largest that we have on there is going to be the 8. Next largest is going to be the 7 and some change, which would be that square root of 51. And then finally our 7. So there's our final answer. Whew, one more. Alright. A microscopic cell measures 3.8 times 10 to the negative 3rd centimeters in diameter. What is the number in standard notation? And zoom on in here. This is a lot like that one that we did earlier. In fact, I'm actually kind of wondering if it's the same one, but whatever. So here's a number. I'm going to write the 3 and the 8 down. We have a negative exponent, which means our decimal here has got to go that way to make our number smaller. So we're going to move it over 3 places. So I'm going to move it over 1, 2, 3 places. There's our new decimal. I'm going to fill in my zeros. And again, I like having the 0 at the beginning. This sure sounds really familiar. I'm pretty sure it's the same one we did earlier. While that is good enough, I'm going to go ahead and rewrite it. 0, 0, 3, 8. And there's our number in standard notation. Alright, good luck on the test on Friday, guys.